Hello friends, welcome back. In the previous video, we have seen on the iris dataset, we were able to implement SVM and we have seen like how linear and nonlinear SVM will be working on this iris dataset. Now, we also have an option to create one dataset, custom dataset for this. So, example, sklearn datasets, we have a library where we can import something called as make moons. Okay, so moon shaped kind of a thing distribution. We can do that, and for that, I'll be using from sklearn datasets import make moons. So here I can generate a XY points, I mean the distribution in such a way that, okay, I can set like number of samples, how many samples I do what, right? And I'll be able to generate a, along with the noise, okay? So I'll be able to generate that. How do I do that? I have X comma Y, make moons, how many samples do I want to create? 200. And noise, I am keeping it as 0.2. You can increase the noise and check like what is its effect. And similarly, right, random state 42, right? So this I have explained in the previous video, right? So now remaining everything is same. The remaining step would be splitting the data set, 70-30 data set, I mean train and test, right? Then what I'll do is in this video, so let's train both logistic regression as well as um, non-linear SVM and check like how what is the difference when I use logistic regression and when I use, okay, let me run this. When I use logistic regression versus SVM, okay, what is the difference, right? So what I'm doing is I've splitted the data, then I've just copy pasted the logistic regression ka program and then SVM ka with RBF kernel. You remember this gamma value, C value I have explained in the previous video, right? Same thing. Now I'll plot both of them and observe like what is the difference between logistic regression on the same data set, moon data set, and wow, fantastic, right? So you can see like how many misclassifications are there. That means misclassification. I say like there are so many blue points in the red area and the red points in the blue area, right? There are so many misclassifications happening, right? So when I use RBF, you can see like how clean the classification is. Maybe one or two points messed up, but compared to this, right? So it is so clean, right? I hope you now realize that how SVM, kernel-based SVM is better than the normal logistic regression, right? So let me show you one more thing. We can also try out with another kind of a data set, which is like circles data set, right? Same thing I'll show now. So I'll use now same thing. Instead of make moons, I'm using make circles, right? So remaining everything remains same. Okay, splitting the data, logistic regression part, SVM part, everything is same. Okay, only thing is instead of randomly generating the data in the form of moons, now it is in the kernel. I mean, not kernel, circles. Right, you can see how bad the logistic regression is able to work on such kind of a data set. And look at this. Correct. So this is how the data is can be well separated and classified with the help of right non-linear kind of a SVM, right? So in this case, we have seen on three data set: iris data set, moons data set, and circles data set, right? How the comparison can be done with respect to logistic regression and the SVM. Linear SVM we have shown and non-linear, right? Hope you understood clearly what is how SVM and logistic regression works. SVM is considered to be one classical algorithm which works fine even for the regression task as well as the classification tasks, right? So hope you enjoyed the video. See you in the next video. Thank you.